Welcome to our second help video over mass-to-mass stoichiometry. We're looking at the handout 9-10, and the second help video here is over the back of the handout, problems 3 and 4. Again, these are mass-to-mass reactions. When doing mass-to-mass reactions, when we're taking a mass-to-mass stoichiometry, it helps a little bit to have this chart out in front of you. This is our stoichiometry conversion chart, and one of the most fundamental calculations in all of chemistry is where they'll give you the mass of one thing in a reaction and ask for the mass of something else. All we need to do is conversions that we already learned to do. Long ago, we learned that if they give you the mass of one thing and you have a periodic table, you can convert it to moles. Here, on this side of the table, if you have the moles of one thing and you have a periodic table, you can convert it to mass. But when we're employing stoichiometry, if we have a balanced chemical equation and they give you the mass of one thing, you first convert it to moles, and then you use the balanced chemical equation to go moles of one thing to moles of another, because that's what a balanced chemical equation gives you, mole-to-mole ratios. And that's why we spent a tremendous amount of time in Unit 8 learning to write and balance chemical reactions correctly. So let's take a look at the problem right here. How do they get iron from iron ore? One way is to react it with carbon monoxide in the presence of a tremendous amount of heat. And we can get iron out of there. The question they're asking is, how much iron 3 oxide would we need to produce 26.17 grams of iron? So they want to know how many grams of iron, they want to know how much of the iron 3 oxide right here, what mass of this would be needed to produce 26.17 grams of metal, iron metal. That's a mass-to-mass problem. What mass of the iron 3 oxide? What mass of the iron 3 oxide? That's what we're trying to find. Would we need to produce a certain amount of iron? That's our given. So our first step, we're trying to find what mass of iron 3 oxide. That's our question. That's what we're trying to find. Would be needed to produce 26.17 grams of iron. That is our given. So our first step is to convert mass of our given to moles. Right here is where we are. Mass of what we're given to moles. We want mole on top, and the mass of it from the periodic table is on the bottom. We want mole on top and mass from the periodic table is on the bottom. Here there's really no calculations because we're dealing with elemental iron. You look on your periodic table, it is 55.85 grams of iron per 1 mole. How do I know which one's on top? On this chart, we see that we want mole on top, mass on the bottom. Mole on top, mass on the bottom. But if I don't have the chart, how do I know? Well, if I'm given a mass, grams, I need that on the bottom so that it will factor out in dimensional analysis. This unit must cancel with this unit, leaving me with moles of iron. And if I know moles of iron, I can find moles of what I'm trying to find, the iron 3 oxide, by using the coefficients from the balanced chemical equation. Here we go. Here's our balanced chemical equation right here. Be sure you've balanced it correctly. And we see from this equation that it's 2 moles of Fe require 1 mole of Fe2O3. We can write inequality two ways. We can put moles of Fe2O3 on top and moles of iron on the bottom, 2 moles of iron on the bottom, or I can put the 2 moles of iron on top and the 1 mole of Fe2O3 on bottom. Every equality can be written two ways. So how do I know which one of these to pick? One way is to look at my chart. The moles of what I'm trying to find should be on top. The moles of what I'm given is on the bottom, and the coefficients from the balanced chemical equation precede those numbers. So what am I trying to find? Fe2O3, that should be on top. Moles of iron should be on the bottom, and I use the coefficients. If I don't have a chart, how do I know? Dimensional analysis. If this is moles of Fe, I need to cancel or factor it out with moles of Fe on the bottom. This will cancel with this. The grams we saw canceled with grams. And now I'm at moles of Fe2O3. Where is that on the chart? Moles of what we're trying to find are right here, and we're going to mass. I'm going to need the periodic table to do that conversion. The mass from the periodic table is on top. 1 mole is on the bottom. I need to add up the molar mass. Here we go. What is the molar mass of Fe2O3? Well, there's 3 moles of O in there. 3 times 16 is 48. There's 2 moles of iron. 1 mole is 5585. 2 times 5585 is 11170. Add those two up. It's 159.70 grams of Fe2O3 per 1 mole. Which one goes on top? We saw already here that the mass is on top. So we're going to put the mass on top. That's the 159.70. 1 mole's on the bottom. If I don't have that chart handy, I know that moles here need to cancel with moles here. So moles of Fe2O3 cancel with moles of Fe2O3. Moles of iron cancel with moles of iron. Grams of iron cancel with grams of iron. The unit I'm trying to get to is grams of Fe2O3. That needs to be the final unit on top that doesn't cancel. 2617 divided by 5585, hit an equals. Divide that by 2, hit equals again. Times 159.70, hit equals again. You should get 37.42. Our next question, what mass of CO2 would be produced in producing the 2617 grams of iron? So if we're looking at this right here, they said that we're still going to produce 26.17 grams of iron, but how much of the pollutant carbon dioxide would be produced in this process? We're still starting with 26.17 grams of iron. 26.17 grams of iron. The initial step is going to be the exact same. If our given is mass, the only thing we can ever convert a mass to on this chart directly, the only thing you can convert mass to ever in chemistry directly is moles, and you can do that if you have a periodic table of elements. Moles are on top, grams would be on the bottom. We already know that 1 mole is 5585, moles on top, grams on the bottom. If you don't have that chart handy, you just know if grams are here, they need to be on the bottom, so that will factor out. If you have grams on top and grams on the bottom, they'll cancel out. The next step, where are we on the chart right now? We are on moles of iron, and we're trying to get to grams of carbon dioxide, but to do that, I have to go to moles first. This is in blue because this is our new step that we learned. This is our big conversion. This is the step that opened up a whole new area of calculations. And to go from mole of one thing to mole of another, we need the coefficients from the balanced chemical equation. The coefficient of what we're trying to find will be on top. Coefficient in moles of the thing we are at are on the bottom. So we come back from the periodic table, or from our equation, we know it's 2 moles of Fe for every 3 moles of CO2. This is an equality from our balanced chemical equation right up here. We will see from this equation, it's 2 moles to 3 moles right there. 2 moles to 3 moles. 2 moles to 3 moles. The 2 moles of iron can be on top, 3 moles of CO2 can be on the bottom, or the other way. 3 moles of CO2 on top, 2 moles of Fe on the bottom. Which of those do I need? We saw from our chart that the moles of what we're trying to find, preceded by the coefficient, should be on top. We're going to CO2, so that one, the 3 moles of CO2 should be on top. Where we're coming from, moles of iron should be on the bottom. If you don't have the chart handy, we see moles of iron right here. It needs to be right there. So you always have to get this first conversion correct, moles over grams, or the rest of them will be upside down. It's very important to take the time. If you're given grams, this needs to be grams. That needs to be moles. If this is moles of Fe, that needs to be moles of Fe. If we're trying to get to CO2, the moles of CO2 have to be on top. In our last step, Where are we now on the chart? We're at moles of CO2 and we want mass. Our conversion factor is add up the mass from the periodic table and put it over moles. So we're going to need the periodic table to make this happen. CO2 has 2 moles of oxygen in it. 2 times 16 is 32. There's 1 mole of CO2 in it. 1 times 1201, or 1 mole of C in it. 1 times 1201 is 1201. 32 and 1201 is 4401. Which one's going to go on top? Grams on top on our conversion factor. Grams on top on the conversion factor. So the 4401's on top, moles on the bottom. If you don't have that chart handy, if this is moles of CO2, that has to be moles of CO2. This one would go on the bottom so that they cancel or factor out via the dimensional analysis. This label cancels with this label. The factor label method. This label cancels with this label. Grams of iron cancels with grams of iron. The only one that didn't cancel is grams of carbon dioxide. That's thankfully the one we're looking for, grams of carbon dioxide. It's the only unit that doesn't cancel. So on your calculator, you would take 26.17 divided by 5585, hit equals. You could take that times 3, hit equals, divided by 2, hit equals, times 4401, hit equals. You should get 30.93. Or you can multiply everything on the top in hit equals and divide it by and use your parentheses. So you could take 2617 times 3 times 4401 equals divided by parentheses 5585 times 2 times 1 parentheses, and you would get 30.93. This ends our video help on 9-10 practice problems. One of our most important calculations we can do, mass to mass stoichiometry. It's at the heart of so much chemistry. So be sure that you know how to do these. If you're having trouble or are confused, please don't hesitate to email me, contact me. We can set up a meet. We can look at your homework closely when you practice these to see what errors you might be having and discuss those, whatever it takes. Or if you're just comfortable and you want to email back and forth, that's how you want to do it. Whatever works fine. But this is a calculation that you need to have mastery of in the subject of chemistry. We thank you for listening. Have a great rest of your day.